let us write a computer code, or what will be the logic of a computer code to calculate the Lennard-Jones potential for a system of n particle system. So, what I am basically trying to do now, writing a computer code to calculate Lennard-Jones potential of a n particle system. Let's try writing out a computer code, and I'm writing this is in Fortran 77. You can so basically I'll be presenting you the logic, and then you can write in your own language of C, C++, Fortran 90 and so on. So this is a computer code what I'll be writing in Fortran 77. So we have n particle systems, and we want to find out the Lennard-Jones potential. So if you recall the Lennard-Jones potential, it was okay. So my Lennard-Jones potential was ULJ is equal to sum over I, sum over j for epsilon sigma by r ij to the power 12 minus sigma by r to the power 6. So this is the formula what you will be executing. So as I said that for the pair potential, to avoid the same interaction twice, we put an inequality where my I goes from 1 to n minus 1 and my j goes from I plus 1 to n. If you put this, if you maintain this limit, then you are not overcounting the same interaction. You are not counting the same interaction twice. You are not counting 2, 1, since you already have counted 1, 2 interactions. Okay, so to do this, first we have to know the value of epsilon and sigma. So epsilon and sigma, they are the constant values, so they don't change. So what's the variable here we have is basically the Rij. And what is Rij? Rij is nothing but your Ri minus Rj. So Rij is the interparticle distance, the distance between particle I and j, and that's the only variable. So that you have to calculate inside the loops, and epsilon and sigma are the constant values which you can read directly. So we'll start by reading epsilon and sigma. So I can read this on the screen itself, and I read sigma and epsilon. And after I read that, I am calculating sigma square. So sigma square I am calculating by multiplying sigma with sigma. So this is my sigma square. Now I initialize my potential by setting it to 0. So I am now initiating the calculations. So my u to start with is 0. Now I start my do loop. Do I is equal to 1 to n minus 1. And my Rxi is equal to Rx I, my R y I. So basically I am reading the x, y and z coordinates of each particle. So this is the x coordinate, y coordinate, z coordinate of the ith particle. So I am reading 1 to n minus 1 particles x, y and z coordinates. Now since I have to calculate the pair interactions, interaction of I with j, inside this do loop I have another do loop which is j. Okay, so I have to give some number, let us say I am sorry, so yeah, so in the here I need to put a number. So say do, so this is Fortran, do j, do 10, I is equal to 1 to n minus 1. So this is my do loop with 10 is basically the number which I started here and I need to close it later. So I start another loop, do 11 j. So j goes from I plus 1 to n. So now inside this I now calculate Rx ij. So which is basically the distance between the x component of ith and jth particle. So I already have Rxi from here. So I write Rxi minus Rxj. So this is my x component separation between ith and jth particle. Similarly, Ry ij I can write as Ryi minus Ryj. Rz ij is equal to Rzi, which I already have, minus Rz jth particle. So here basically I am looking at the separation of x coordinates of I and j, separation of the y component of I and j, and the z coordinates of I and j. Then what I have to calculate is the Rij square. Because the distance between two particles is square root of xi minus xj square plus yi minus yj square plus zi minus zj square. So Rij square, since I already have Rxij and so I have Rxij, Ryij, Rzij. So Rxij multiplied by Rxij plus Ryij plus so this is my Rij square. And what I need is 12 and 6. So from here I can define SR is 2. So SR is just basically short range. So sigma square because sigma square divided by Rij square. Likewise, I can define SR6, which is SR2 multiplied by SR2 multiplied by SR2, and SR12 is nothing but SR6 multiplied by SR6. So my SR12 is nothing but sigma divided by R to the power 12, and SR6 is nothing but sigma by R to the power 6. So now I need to sum them up. So my U is instantaneous value of U plus SR12 minus SR6, and now I need to close my do loops. So the jth loop is an inner loop, so I need to close that first, and then I close the outer ith loop after I close the jth loop. And once the loop, both loop are closed, I get the total U, which should be multiplied by 4 epsilon. Epsilon I have read, and this 4 epsilon, the constant term, I have to multiply with the U, the final U I get after the loops are closed. So this will be the final potential, Lennard-Jones potential, which I can write on the screen as V. And then I can then I have to basically say stop and end. So from here I have 2 more steps, stop and then end. That will be my 477 code to calculate the Lennard-Jones potential of an n particle system.